Hello everyone, welcome back to the class real-time system. So today we are going to discuss about communication. So what is a communication? What are the things which is involved in this communication? So far we discussed about what are the hardwares are required and what is a specialized processor and how the data will be transferred, what are the techniques are there in this data transfer and what are the interfacings are connected to that. So these are the things which we have discussed about in this previous topics. Now we are going to discuss with the communications on the transmission line, how the data will be communicated. Okay, so the the use of distributed computer system, which implies the need for the communications between the instruments and the plant and the low level computers. So here you can see here there are three levels are divided here: level 1, level 2 and level 3. Level 1 is specifies the parallel analog and digital transmission. Level 2 is nothing but an asynchronous direct and asynchronous network, synchronous network, and level 3 is nothing but an synchronous. Okay, so here you can see here it is a plant, the plant which is connected to the computer. Okay, so these computers are connected to the another level computer, that computer which is connected to the computer. So consider here the overall industry which is controlled by the computers. Okay. So at the plant level, the communication system that typically which involves the parallel analog to digital conversions. Okay, so the signal transmission techniques, because the distance for the communications are very small and also high speed communications are usually required. So that's why we are going for the parallel and also analog to digital transmission. At the higher level, it is more usual to use a serial communication method because the communication distance extends beyond a few hundreds of yards. So as a result, the use of the parallel cable rapidly becomes the difficult and also it is nothing but the costlier one. So that's why we are going for these types. Okay, so the analog systems are generally limited to the short distance. The parallel digital transmission provides the high data transfer rate, but it is expensive in terms of cabling and also interface circuitry and normally used for the short distance. So when I come to this communication, when I come to the serial communication, there are a number of the techniques, serial communication techniques that can be characterized by several ways. When I come to this mode, it may be an asynchronous or it may be a synchronous transmission. When it is on quantity, the character by character also can transfer, or block of data can also be transferred, and distance, it is on local or it is on the remote, that is the wider area networks, and code, ASCII code and also the other part of the course can also be transferred. So the first one is asynchronous and synchronous transmission techniques. So first we are going to talk about the asynchronous techniques. So the asynchronous transmission, which implies both the transmitter and receiver circuit use their own clock cycle. Okay, so there is a different clock cycle for each and every circuits that generates the gate signal which is on or off the data transmission lines. So there must be some agreement between the transmitter and receiver to receive the data. The clock signal agreement between the transmitter and receiver to synchronize it. So the most common asynchronous transmission system is nothing but the character by character systems, which is frequently used for connecting the terminals to the computer equipments, and that was introduced by the transmissions of information over the telegraph line. It sometimes which is called start and stop bit. So there is a synchronization between the transmitter and receiver, that is by start and stop it. So here also there are multiple methods are there. So generally which is called start and stop it. So whenever it is started sending the start signal, the receiver will come to know the transmitter is ready to send the data. So during that time the receiver will be ready to receive the data from the transmitter. So here you can see here this diagram, the clock signal, the above one is nothing but the clock signal which is represented here, the start time, and also it is stop time which is represented. In between that the data will be sent. So these data will be received by the receiver. Okay. So the each character is transmitted, it is preceded by the start bit and followed by one of the two stop bits. Okay, so the transmission is bit synchronous but the characters are asynchronous. So there is some advantages of advantages that low transmission rate. So the clock signal generates do not have to be closely matched, and disadvantages is that for each character send 3 or 4 extra bits can also be transmitted. So the overall information ratio is very It's not very high. So to overcome the problem, the synchronous system designed to transmit the large volume of data over the short period of time using the block synchronous transmission techniques. So the characters are grouped into records. The example, blocks of 80 characters, and each record is preceded by the synchronization signal and the terminated with a stop sequence. Okay. Additionally, it makes the use of the protocol, a simple protocol shown in the figure. So this is the simple protocol. So in the simple protocol you can see here EOT, BCC, ETT and text, STX, and then SYN, BCC, ETX and then text. So these are the information central given. So the bit synchronization is achieved at the start of the transmission by sending out of the sequence of ones and zeros followed by the ASCII code SYN. Okay, and then the continues to send the SYN code until the receiver responds by the sending back acknowledgement signal. So in case a timeout occurs, the sender resends a bit pattern and also a code. So once the contact is established, the transmitter sends the SYN characters during any ideal period, and also receiver will respond by send back acknowledgement signal. Okay, so the text is broken into the block and each block is presented by the STX. It's nothing but a start of text. So the character and ends with the ETX. ETX is nothing but end of the text. It is nothing but a character. So the following ETX there will be an integrity check on the data. It is typically the parity check bit. Okay, so there are two main standards of synchronization transmission. One is BIS, the BiSync and also a HDLC. It is nothing but the binary synchronization, synchronous communication. So this is an older system which is used in IBM equipments and it is obsolete. Okay, HDLC is nothing but the high level data link controller. This is used in most of the new equipments. So in synchronous transmission, the clock signals for the timing which is provided independently and by the transmitter and the send to the receiver even when no data are transmitted. So no need to send the extra bits in the to enable the synchronization. Hence the effective data rate is higher, but the interface circuitry is more complex and also a expensive one. So these are the local area networks, local area and wide area networks. So the local area and wide area networks, okay, the wider area networks have existed for the many years and they operate over the wide range of geographical areas. Okay, so the local area networks is a more recent development. It is having a considerable impact on the design of process control equipments. So the typically these topologies are the bus structure, that is data structure, and also a star hierarchy and also a ring and mesh topologies. Okay, so the first one is nothing but the data bus. So the data structure, the data bus is nothing but it is in simplest form of all the LAN topologies. The bus is normally a passive and all the devices are simply plugged into the transmitting mediums. And second, the star. The star is not widely used. It depends on central switching node to which all other nodes are connected by the bidirectional link. And the third is hierarchy. The third one is a hierarchy. It has many of the nodes acting as switch. And the next is ring, the most popular method. The ring itself contains the regenerator circuit which amplifies the signal. The information placed on the ring network continues to circulate until the device which removes it. And the next is mesh structure. The mesh structure is nothing but it's connected, the random connections between the one node to the another node. Okay, so it is point to point communications can be transferred to any other devices. So these are the local area networks and also a wider area networks. Okay, and local area and wider area network which uses the form of packets. It's a fixed or variable length. So early system which uses the character oriented packets as shown in the previous topics. The HDLC. So the HDLC format which will be used like this. So it will be sending the delimiter, start delimiter, and address will be sent, control signal, data and checksum, and end delimiter will be sent. Okay, these are the references. I hope this topic is very useful for you. We'll meet you in the next video. Thank you all.